Hi, this is Malidumala Santamburalage, and this is my network traffic analysis live presentation. I'll be starting Wireshark, and in this one, I will select Docker 0, which runs MQTT broker Mosquito. And when I start walkthrough, it should display the traffic in Wireshark. Yeah, this is the application. And after running the application for few minutes, we can see some traffic over at Wireshark. So let me type MQTT in the filter box, and we'll see all the MQTT messages here. And there are three main message types here. So that's connect, subscribe, and publish. And what the connect does is that it is used by the client to request acknowledgement from the MQTT broker, and the subscribe message is used when the MQTT client requests messages of MQTT topics from the broker, and the publish messages are used when the MQTT client sends out messages of topics to a MQTT broker, and vice versa. And the answer for the mini challenge, which is what is the topic that is used to publish the message when we alter the temperature here in the application? That is home/temperature/set. And after we leave the application running for a few minutes, we can see another two types of MQTT messages. That is ping request and ping response. These messages are used to keep the connection between the broker and the client alive. The request is from the client and the response is from the broker. This is task 2. Now I will open functionalize.pcap here in Wireshark to observe how the topic hierarchy works and to observe the payload scheme used. So I will type MQTT here in the filter box. And as we can see, the topic hierarchy flows from home to light control such as status, control, and mode. Under the home topic, there could be many more systems such as air conditioning units and security cameras. Here, however, under the system topic lights, we can see properties which we can alter such as status, control, mode, schedule, color, and brightness. So the payload follows a very simple comma separator strings for structured data. We can see here under status it's just on or off, and under color it is an RGB value, and under brightness it's an integer. So here it's 0. This is the controller. Now I will attempt to restore its functionality. So first I will change the control mode to manual. There you go. And now I will turn on the lights. Now I will change the color of lights from red to white. Here you can see I use the RGB values of this 255, 255, and 255 for color white. There you go. And now I will reset the lights schedule to 9 a.m. to 6 p.m. There you go. And that's the successful alert. Threads to the IoT systems, which are an attacker could manipulate the temperature of the HVAC system. If there are no limits set to the temperature, it could be dangerous to the occupants, especially children and pets. If it's a business, an attacker could manipulate the light system to damage the reputation of the business and cause financial loss. Hardening strategies we can use are authentication, assign username and passwords to clients to securely connect to the broker. Authorization, set up an access control list to control which client can publish to certain topics. Encryption, by using transport layer security, we can encrypt the MQTT messages, avoid an attacker sniffing packets and reading them through applications like Wireshark. Mitigation links are set up a username and a password to access the HVAC system, preventing an attacker gaining access to the temperature controls. Set up a TLS encryption so an attacker cannot read the payload schemes used in the lighting system. This will limit the attacker's understanding of the operation of the system.